Hi everyone, I'm Won Lee. I just started to explain sample and what distribution of X. Not yet, but anyways, sample theory. Okay, I'd like to introduce new terminologies, parameter and statistic today. Okay, just review a little this one. Okay, there is population. We denote it by X, random variable X. There are many unknown values, many values. So X will have follow some probability distribution. Okay, you got it. We take some sample part of population like this. First, as you have known so far, sample is data, x1, x2, xn, and values, realized numbers. Okay, so small letter. But here, I told you yesterday, we can denote sample by capital letter. Capital letter means random variables. So n random variables like this. Okay, we call this one sample, and this one also we call sample. What is this? This real number, realized values is through what? Survey procedure. You just take real numbers, n many real numbers, measure the values of n random variables. You understand it? And another notation, we have a sample x1, x2, xn, iid f of x. What is this? Identically, independently distributed. You can change it, okay? You may change this independently, identically. So this is not very complicated. So in other words, x, x, x. What? How many? N many. N many unknown values. That is a sample. But you have to distinguish it from single x. That's why they use subscript 1, 2, n. Okay? So in other words, you may ignore the subscript, this one. Then x, 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 x. So x, 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 what? Independently, identically distributed. What distribution? Axis distribution, f of x. Okay? It's just simple, but it is important. Okay, today I'd like to introduce parameter terminology, statistic. This is a common noun. Okay? So small letter s. In relation to the population, unknown values of the population, unknown, there are many data, unknown data. So there are many data. How to represent this many unknown data? There is what does it mean? There should be exist mean, right? So we say mu as mean, okay? And also there are many data, unknown data here, right? So they are what? Dispersion. The data has spread, dispersion. So we denote it by sigma square. These called mu and the sigma square or sigma called parameters, unknown value. While the result obtained from the sample are called statistic. What is a sample? x1 up to xn, capital letter. Then there will be x bar. And the small letter, x1, xn, realized values, there will be what? Small x bar. This is a calculated sample mean. This is not calculated yet, so theoretical sample mean. Understand it? For example, parameters include the population mean, mu, and the standard deviation, sigma. Since we do not know the values that make up population, the mean and standard deviation of the population are unknown values. These are called parameters. In this case, the result obtained from the sample, from this type of sample or this type of sample, okay? The result obtained from the sample that correspond to the parameters, correspond to this parameter mu x bar or small x bar. Both of them are called statistic. The sample mean, x bar, corresponds to the population mean mu, and the sample variance, sample variance s square, or small letter s square, calculated value, right, correspond to the population variance sigma square. And the sample variance is expressed in either way, two ways, capital letter, small letter. Can you understand it? That's good. That will be perfect. Okay? Next, again, I like to repeat this one again. Parameter and the statistic. Unknown value of the population is called parameter. Any result obtained from a sample is called statistic. A statistic is a function of a sample. Function of sample. This one. Xn. Anyone. If, for example, you say x1 plus x2 divided by 2, there are n many, okay, n many x's. But if you got this one, first sample value, second sample value, unknown, not yet, divided by 2, this is what? Statistic, okay? Any result obtained from a sample is called statistic. C, population, size, capital N many, or infinity, okay? So these are unknown values. There will be mu. There also will be sigma square. We call them parameter. Okay, sample, size n, small n, capital letter sample, x1, x2, xn. Still, we do not know the values. Not yet. x1, x2, xn, random variables. Then from this one, we can calculate the x bar. X bar is what? X bar should be x1 plus dot dot xn divided by n, right? And s square, I just show you s square, capital letter, because these are capital letter, xi minus x bar square sum divided by what? Degree of freedom, n minus 1, right? And the realized value sample, size, of course, size n. I told you this one is matching or corresponding. Small x bar, calculated some number. We call them also statistic, okay? You get it? I hope you understand briefly this kind of a thing about the sample and the terminology, parameter, and the statistic. Unfortunately, there are many statistics textbooks do not adequately convey the fundamentals of statistics. This is the fundamental. These are fundamental of statistics, I think. I dare to say the reason why statistics is perceived as difficult is that many textbooks do not distinguish between uppercase, lowercase letters sample when explaining samples. It is very, very important. Some textbook only express a sample like this. Then you cannot follow the statistics theory, anything. Okay? If one does not learn about the samples accurately while studying statistics, he or she becomes challenging to grasp the system of statistics. They, fall in a fog, I think. That's why many persons do not like statistics. Many persons say statistics is pretty hard to understand. But it is very, very simple, easy, and I told you, straightforward. So in this lecture, I like to emphasize this kind of a thing. Okay? Okay, it's it. Thank you. Bye.